whiteboard it. All right, so first question on our exam says, which of these is the derivative of h of x equal to secant of 5x plus 4? All right, so this is a chain rule problem. Secant is my function on the outside, 5x plus 4 is my function on the inside. All right, so first up, what is the derivative of secant? If I had secant of x, the derivative would be secant x tangent x. So h of x here, h prime of x will be equal to, so I'm going to take derivative of the outside and leave the inside alone. I will have secant of 5x plus 4 times tangent of 5x plus 4. So all of that right there constitutes derivative of the outside times derivative of the inside. Derivative of the inside here, the derivative of 5x plus 4, simply just equal to 5. So the answer here is going to be answer D. All right, problem number 2. Which of the following is the derivative of g of x equals sine of x cubed plus 1? It's a really very similar type of a question. Again, this is a composite function. My outside function here is sine of something. The inside function is x cubed plus 3. So the derivative, g prime of x will be equal to, derivative of sine is equal to cosine, and I'm going to leave the inside alone, x cubed plus 1, times derivative of the inside, derivative of x cubed plus 1 equal to 3x squared. All right, let's see. Answer here is going to be answer B. All right, problem number 3. Says, which of these is the limit, limit as x approaches 2, of x squared plus 3x minus 10 over x squared minus 4? All right, so remember, anytime we approach a limit problem, the first thing we always try to do is just plug that limit in, just to see what we're dealing with. If I plug 2 in here, I will have 4 plus 6, which is 10 minus 10. So I get a 0 in the numerator, and I get also a 0 in the denominator. So anytime you see that a limit is equal to 0 over 0, it means that the limit probably exists. We just have to go about it a different way. All right, so you've got two options here. Either you can factor. So what I would do here is to go ahead and say, all right, I identify here. I can see that the numerator is going to factor into x minus 5x plus 2. And then the denominator is going to factor into x minus 2, x plus 2. So I have this common term that will cancel out. And after I cancel this common term out, we try to take the limit again. So now when I plug in 2, I have 2 minus 5, which is equal to negative 3. And I have, let's see, 2 minus 2, which is equal to, you know what, I flipped these two guys around. Sorry, hold on, my signs were wrong. This is a plus 5, I'm sorry, that was a plus 5 and a minus 2. All right, so the minus 2 cancels with the minus 2. Sorry, so this term is still here. So when I plug 2 in here, I get a 4 in the bottom, and so we get negative 3 over 4. Sorry about that. All right, answer here is B. Also, you could have said that since the limit is equal to 0 over 0, you could also have used L'Hopital's rule. So alternatively, by L'Hopital's rule, we could have said that this limit is equal to the limit as x approaches 2 of the derivative of the numerator is equal to 2x plus 3 over the derivative of the denominator, which is equal to 2x. All right? What's wrong?
You actually have to put the answers. The answer should be 7/4.
Oh, did I? Okay, I plugged it in wrong. Okay. You're right. It is 7/4. All right. Well, we would have discovered that in just a second. All right, so down here, If I plug 2 in, 2 times 2 is 4, plus 3 is equal to 7. Plug 2 in down here, 2 times 2 is equal to 4. Sorry, yes, your answer is 7/4, not B. Sorry about that error. All right. All right, so like I said, either by factoring, obviously by factoring, I just really fumbled it and made a careless error. If there's 2 ways of doing something, use that second way to double check yourself. If you had made a careless error like this, you would have caught that careless error by trying with the different technique here. All right? Okay, number 4. Which of the following is the derivative of f of x equals x to the 4th times cosine of 3x minus 5? All right, so what I have here is a product between 2 functions, and then the second component actually is also a composite function, so we'll be using the product rule as well as the chain rule. All right, I'm going to kind of just move this up so I can work down here. So f prime of x will be equal to, according to the product rule, derivative of the first, derivative of x to the power 4, is 4x cubed times the second, leave the second alone, cosine of 3x minus 5, plus the first, x to the power 4, times derivative of the second. All right, so now here's where we're going to use the chain rule. The derivative of cosine of 3x minus 5, derivative of the outside, derivative of cosine is equal to negative sine, leave the inside alone, 3x minus 5, times derivative of the inside. Derivative of 3x minus 5, simply just equal to 3. All right, so we can clean up here. If we combine some things, we get that this is equal to 4x cubed times cosine of 3x minus 5. I'm going to combine the 3, the negative, and the x to the power 4. This will give me minus 3x to the 4th times sine of 3x minus 5. Let's see, this is going to be equivalent to answer C. We get answer C here. All right, number 5. All right, again, which of the following is the derivative of f of x equals x squared times e to the 5x plus 1? Again, we have a product between 2 functions, but my second function here, again, is a composite. So I'm going to be using the product rule as well as the chain rule. Here we go. F prime of x will be equal to derivative of the first. Derivative of x squared is 2x times the second, e to the 5x plus 1, plus the first, x squared, times derivative of the second. Now, derivative of e raised to some function, is e to that function, so e to the 5x plus 1, times derivative of the inside. The derivative of 5x plus 1 is just equal to 5. Again, if you rearrange, you will get that this derivative is equal to 2x times e to the 5x plus 1 plus 5x squared, e to the 5x plus 1. Let's see, our answer here is going to be, looks like answer E, right? 5x squared, yes. My answer here is going to be E. All right, any other questions or concerns so far? Doing okay. All right, number 6 says, which of the following is an equation for the line that is tangent to the graph of f of x equals x cubed minus 7x plus 9 at x equal to 2? Guys, being in Calculus 1, we're almost 100% sure you're going to get a question like this somewhere on the exam. Find the equation of the tangent line. All right, so to find the equation of a line, we need 2 things. We need to have its slope, and we need to have a point that it is passing through. So step 1, I'm going to find the slope. All right, so we know synonymous with slope is derivative. So f prime of x is equal to 3x squared minus 7. So straightforward derivative. So in order to actually find the slope m is going to be this function evaluated at this point of interest. So evaluate at 2. So 3 times 2 squared minus 7. Let's see, 2 squared is 4, times 3 is 12, minus 7 is equal to 5. All right, very good. We're done with step 1. Step 2 is going to be to find the point. And specifically, I already have the x-coordinate of the point. I need to find the y-coordinate of the point. So that y-coordinate that I'm looking for is going to be the original function evaluated at 2. So that'll be 2 cubed minus 7 times 2 plus 9. So let's see, 2 cubed is equal to 8, minus 14 plus 9 is equal to minus, is it minus 13? I think it's minus 13, right? So let's see, minus 14, 8. No, 8 and 9 is, no, I did it wrong. 8 and 9 is 17, minus 14 is equal to 3. You guys get 3? So I get that y naught is equal to 3. So that means the point that we're passing through is the point 2, 3. And so finally, in the third thing I'm going to do is to put everything together using point-slope form. So find the equation. So using point-slope form, y minus y naught is equal to m times x minus x naught. And let's plug in. So y minus 3 is equal to 5 times x minus 2. And let's clean up. Y minus 3 is equal to 5x minus 10. So y is equal to 5x minus 10. I'm going to add 3 to both sides. So I get that y is equal to 5x minus 7. The answer here is E. All right, everybody following along still? All righty. All right, problem number 7 says that the derivative of a function f of x is given by f prime of x is equal to 9x squared minus 8. If f of 1 is equal to 10, which of the following is the formula for f of x? All right, so we're finding an antiderivative, a, e, and integral. All right, so first of all, f of x will be equal to, so if I find the antiderivative here, or the integral, remember for a polynomial function, we use the rule add 1 over add 1. So I will have here 9x. If I add 1 to that exponent of 2, it becomes 3. And we divide by 3. Minus, when we find the antiderivative of a constant, we just multiply by our variable. 8 times x. And then we stick a plus c on that guy. I'm going to clean it up just a little bit. So f of x is equal to 9 over 3. This is equal to 3x cubed minus 8x plus c. All right, let's go ahead and evaluate. F of 1 is equal to 10. So f of 1 is equal to 3 times 1 cubed minus 8 times 1 plus c. And altogether, this is equal to 10. All right, so 3 minus 8 is equal to negative 5. So I have negative 5 plus c equal to 10. If I add 5 to both sides, I get that c is equal to 15. And therefore, my function f of x is equal to 3x cubed minus 8x plus 15. So my answer here will be D. All right, problem number 8 says that a particle is traveling around a circle x squared plus y squared equal to 25. X and y here are measured in millimeters. At the instant that the particle is at the point 4, negative 3, dx dt is equal to 12 millimeters per second. Find dy dt at this time. All right, so what you can do kind of to make things easier, since we know that we're solving for dy dt, I'm going to take this equation and go ahead and just put y squared on one side. So y squared is equal to 25 minus x squared. And I'm going to go ahead and find the derivative with respect to t of both sides of this equation. All right, so the derivative of y squared is equal to 2y times dy dt. Derivative of a constant is 0, minus the derivative of x squared will be 2x times dx dt. Now remember, we are solving for dy dt, so I'm going to divide both sides by 2y. So dy dt is equal to negative 2x dx dt divided by 2 times y. If you would like, you can go ahead and cancel out the 2's. And now let's evaluate. All right, so if I plug everything in here that I know, this will be minus. I know that x is going to be equal to 4 at this instant. And dx dt is given. That's equal to 12 millimeters per second. All of this divided by y, which is equal to negative 3. All right, and we calculate. All right, so 12 divided by 3 is 4. 4 times 4 is 16. Negatives cancel out. This is simply equal to positive 16 millimeters per second. All right, so answer here will be answer choice E. All right, number 9. There you go. Number 9 says, which of the following is the limit as x approaches 0 of sine of 2x divided by 3x. All right, so again, there's more than one way that this problem can be approached. I'm going to remind you guys that we have a trig identity. Remember, we talked about the trig identity that said that the limit as theta approaches 0 of sine of theta divided by theta is equal to 1. Let me give that a second to get caught up. So if you'd like, you could use this identity at this point in time. To be able to use this angle on the sine has to be the exact same thing as our denominator. So that this means I need a 2x in here in the denominator and not a 3x. So what you can do is we can pull the 3 out and we can multiply both the top and the bottom by 2. So what that would give would be the limit as x approaches 0 of 2 over 3 times sine of 2x divided by 2x. Again, I just multiplied both the top and the bottom by 2. So the 2/3 is a coefficient or a constant that's going to factor out, and then this limit is equal to 0. So this will be equal to 2/3 times the limit as x approaches 0 of sine of 2x divided by 2x. So like I said, according to this trig identity, this whole limit right here, everything in here goes to 1, which means that this guy is equal to 2/3. All right, so our answer here is B. Yes, you could also have used L'Hopital's rule if you had done this the other way around. Let's say we use L'Hopital's rule to find the limit as x approaches 0 of sine of 2x divided by 3x. So if we were to just plug 0 in here, sine evaluated at 0 is equal to 0. If I plug 0 in here, 3 times 0 is equal to 0. So because we get that 0 over 0, we know that this expression is already in that correct form where we could use L'Hopital's rule. So that means this limit will be equal to the limit as x approaches 0. Let's see, the derivative of the top, derivative of sine of 2x. I would have to use the chain rule. Derivative of the outside, derivative of sine is equal to cosine of 2x times derivative of the inside. Derivative of 2x is equal to 2 over the derivative of 3x is equal to 3. And now you can try and plug that limit in again. If we plug in 0 here, plug in 0 for x over here, Cosine evaluated at 0 is equal to 1. Hence, we are simply left with 2/3. All right, so two different ways that you could have gotten to this answer. Which way do you guys prefer? L'Hopital's? Okay. All right, problem number 10 says, which of the following is the second derivative of the function x cubed times e to the 2x? Again, we're going to have to use both the product rule and the chain rule. Here we go. All right, so the first derivative, f prime of x is equal to, according to the product rule, derivative of the first times the second, e to the 2x, plus the first, x cubed, times derivative of the second. Derivative of e to the 2x is derivative of the outside, e to the 2x, times derivative of the inside, which is just equal to 2. All right. If you want to, you can just regroup this. This will be 3x squared times e to the 2x plus 2x cubed, e to the 2x. All right, so we are looking for then the next derivative. We're asked to find the second derivative. All right, so here we go. F prime prime of x is equal to. All right, again, so for each one of these two groups, it's kind of the same thing. It's going to be product rule as well as chain rule. All right, so for this first guy over here, the 3x squared times e to the 2x, according to the product rule, derivative of the first, derivative of 3x squared, 6x, times the second, e to the 2x, plus the first, 3x squared, times derivative of the second, e to the 2x times 2, chain rule. All right, plus, now, derivative of this second component right here. Again, according to the product rule, derivative of the first, derivative of 2x cubed, is 6x squared, times the second, plus the first, 2x cubed, times derivative of the second, e to the 2x times 2. And now we just have to really clean up. We're going to combine like terms. Let's see, I have the terms that contain the x cubed. There's really just one of those. I have a 2x cubed times e to the 2x times 2. 2 times 2 is 4. So I have 4 x cubed e to the 2x. All right, the terms that contain an x squared are these two guys. I have a, let's see, the 2 times 3, so I have a 6x squared e to the 2x plus 6x squared e to the 2x. So altogether that is plus 12x squared e to the 2x. And then finally the term that only contains the x. So that'll be plus 6x e to the 2x. All right, so answer that works here is going to be, let's see, the 6x plus 12 plus 4. Answer that works here is answer A. All right, any questions or concerns before we move on? All right, problem number 11. Which of the following is the limit as x approaches infinity of 4x plus 3e to the x divided by 5e to the x? All right, if we plug in infinity here, I'm going to go ahead and just see what we're dealing with. If I plug in an infinity, we get an infinity in the top, we get an infinity in the bottom. And frankly, I enjoy seeing infinity over infinity because this means I don't even have to clean anything up. This limit or this expression is already in the right form to where I get to use L'Hopital's rule. All right, so by L'Hopital's rule, this will be equal to the limit as x go to infinity of the derivative of the top will be 4 plus 3e to the x divided by the derivative in the bottom, simply just 5e to the x. And we try to plug in our limit again. If we plug it in, we get infinity over infinity. So once more, we get to use L'Hopital's rule. All right, so this will be equal to the limit as x go to infinity. All right, the derivative of 4 plus 3e to the x is just 3e to the x over the derivative of 5e to the x, 5e to the x. Now, before I try to plug in this limit again, I'm going to clean it up. E to the x terms cancel out with each other here. And so really what I have here is the limit of a constant. Limit of a constant, well, it's just equal to that constant. So this guy is equal to c, 3 over 5. All right, and so another problem. All right. Next up, problem number 12. So I left a little room here. Before we get into problem number 12, I know that half of you guys in here are in John's class, and he doesn't always teach things like this, but there are two derivatives that come up really, really frequently that we like to kind of memorize instead of having to do the long way each time. And so the two derivatives that I'm talking about is if we have the function 1 over x, what will the derivative be equal to? Wait for that to come out. Okay, there it is. The derivative will be equal to, so if you kind of do this the long way, we will say that, all right, f of x is equal to x to the power negative 1. And so hence the derivative then, f prime of x is equal to negative x to the power negative 2. And so when we clean it up, f prime of x is equal to negative 1 over x squared. All right, so we committed this guy to memory. All right, so we don't have to reinvent the wheel each time. The other one is going to be, let's call it g of x is equal to the square root of x. The derivative of the square root of x is equal to 1 over 2 times the square root of x. You can prove that to yourself. This is x to the power 1/2. So when we take the derivative, this is equal to 1/2 x to the power negative 1/2. And when we clean this up, this is equal to 1 over 2 times the square root of x. So again, knowing this, being able to go straight for this guy is going to make larger problems a whole lot easier, if we know that. All right, so for problem number 12, we are looking for the derivative of g of x that is equal to 5 times the square root of 3x plus 1. All right, so the derivative g prime of x here is equal to, 5 is a coefficient, just hold them over. Just put 5 down. Now, this is going to be a chain rule problem because this is not just the square root of x, it is the square root of a function of x. So it's going to be derivative of the outside times derivative of the inside. All right, so derivative of the outside, derivative of a square root is equal to what? We just showed that, right? It is 1 over 2 times the square root. Leave the inside alone, 3x plus 1, times derivative of the inside. The derivative of 3x plus 1 is equal to 3. All right, so we can clean up just a little bit. I have 5 times 3 over 2. I think that's going to be equal to 15 over 2 times the square root of 3x plus 1. I don't think much else is going to clean up or cancel out. So the answer here is going to be answer A. All right. Number 13 says, which of the following is the derivative of the natural log of x cubed plus 1? All right, so again, we remember that the derivative of the natural log of x is equal to 1 over x. So the derivative of natural log of a function is going to be 1 over that function times the derivative of that function. So in this case, 1 over x cubed plus 1 times, so this is derivative of the outside, times derivative of the inside. Derivative of x cubed is equal to 3x squared. And if you want to go ahead and write this directly in the numerator, that's absolutely fine. All right, so this is equal to 3x squared over x cubed plus 1. So the answer here will be Answer C. All right, problem number 14. Which of the following is the derivative of g of x equals 2x plus 1 raised to the power 5/3? Again, by the chain rule, g prime of x will be equal to derivative of the outside. So the outside is something raised to the power 5/3. So that derivative will be 5/3, leave the inside alone, 2x plus 1 raised to the power 5/3 minus 1. So 5/3 minus 3/3 is equal to 2/3 times derivative of the inside. Derivative of 2x plus 1, simply just equal to 2. So this, if we clean up, will be equal to, let's see, 10/3 times 2x plus 1 raised to the power 2/3. So the answer here is going to be, looks like B, right? 10/3, 2x plus 1 to the 2/3. Answer B. All right, so this concludes part 1. Let's see, what time is it? It took us about 30 minutes, right? It took us about 30 minutes to do part 1. All right, and so that's with me showing every little step, giving complete, thorough explanations, so you guys can see that it's time-wise, the exam should be comfortable for you. All right, you have time to go back and double-check for careless errors like in problem number 2. All right, so we are now on part 2 of the exam, so at this point in time, you can use your calculator. Problem number 1 wants me to determine the values of a and b, if they exist, using the graph of f of x. So, first of all, we're looking for, a is defined to be the limit as x approaches 1 from the right-hand side of f of x. All right, so as I approach 1 from the right-hand side, so remember, it means that I'm approaching this pink dotted line from the right-hand side. So as I come in from the right-hand side, my function value seems to be going to, my y value ends up at -3 right here. So this is equal to -3. All right, we're also looking for the limit as I approach -3. And this is the general limit. So for this limit to exist, the limit from the left and the limit from the right has to be equal, right? All right, so let's see. If I approach -3, here's x equal to -3. As I approach from the left-hand side, my function value, my y value, seems to be going to -1, right? As I approach from the right-hand side, I'm coming to the same point. Therefore, the limit does exist, and the limit is equal to that point, -1. So the answer here, -3, -1, answer is B. If they had flipped this around, if they had asked for one of these, what is the limit in general as x approaches 1? What would that limit be equal to? D and E, right? Because you see on this side, coming from the left and coming from the right, those two functions don't meet up, right? Or the function doesn't meet up at that point. Those two parts of the graph do not meet up. So the limit does not exist at 1. However, the limit from the left or the limit from the right could be defined, right? Similarly, if they asked you here, what is the function value for this function f of x at -3? The function value. If they simply just asked you, what is f evaluated at -3? What would that be equal to? You see, it's not defined right there, but it is defined down here. So that, I know this is a really ugly copy, but this dot right here means that the function value will be -2, right? So the function value is different from the limit in this particular case. All right, problem number 2. It says, find an equation for the line that is tangent to the curve 8x equal to y squared minus 5y plus 16 at the point 2, 5. All right, so there's no way for me to express this as a function y in terms of x. Therefore, I'm going to have to use implicit differentiation. I'm going to find the derivative with respect to x. So when I find the derivative of a term containing an x, we just find the derivative as usual. But when I find the derivative of a term containing a y, I'm going to tag on dy dx to indicate I just took a derivative of y with respect to x. All right, so here we go. The derivative of 8x is equal to 8 equals the derivative of y squared is equal to 2y, but remember, tag on your dy dx. I just took a derivative of y with respect to x, minus the derivative of 5y is equal to 5 times, again, dy dx, and of course the derivative of a constant equal to 0. All right, so my goal here, I'm looking for the slope of this tangent line, hence I'm looking for the derivative. I'm trying to solve for dy dx. So on the right-hand side, I can factor out the dy dx. So 8 is equal to dy dx times 2y minus 5. And then I can divide both sides by this residual term, and that will give me that dy dx is equal to 8 times, or 8 divided by 2y minus 5. All right, so this is my derivative. Hence, I can find the slope of this line. So the slope will be equal to this derivative, dy dx, evaluated at this point, 2, 5. So if I plug in, this will be equal to 8 divided by 2 times 5 minus 5. So 2 times 5 minus 5 is equal to 5, so this is equal to 8/5. So I can say then that this slope m is equal to 8/5. All right, so they're dealing here with decimal values. 8/5, of course, is equal to 1 3/5. Or so as a decimal, you can give this as 1.6 if you'd rather use decimal values. All right, so next up, we have to actually find the equation of the line. So using point slope form, y minus y naught is equal to m times x minus x naught. All right, so my point x naught, y naught, of course, 0.2, 5, so I'll plug that in. My slope was equal to 1.6. I will have x minus 2. And we clean up. So y minus 5 is equal to 1.6x minus, let's see, 1.6 times 2 will be equal to minus 3.2. And I'm going to go ahead and add 5 to both sides. So y is equal to 1.6x minus 3.2 plus 5. So I get that y is equal to 1.6x. Let's see, minus 3.2 plus 5. If we add 5 to this, it's going to be equal to I get 1.8. All right, so it looks like A is my answer here. I'm going to choose answer A. All right, number 3. Problem number 3 here says, which of the following represents the derivative of f of x, which is equal to tangent of 4x plus 2? So I'm going to remind you guys the definition of the derivative, generically given, is equal, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is our definition. So if we plug our function tangent of 4x plus 2 in there, this will be equal to, let me do it down here, f prime of x will be equal to the limit as h approaches 0 of, all right, so this function evaluated at x plus h will be tangent of 4 times x plus h plus 2 minus tangent of 4x plus 2 divided by h. And we can clean up a little bit here. We can distribute this 4, and so this will give the limit as h approaches 0 of tangent of 4x plus 4h plus 2 minus tangent of 4x plus 2 divided by h. So the answer that I see here that makes sense is going to be, let me see, is it C? Looks like answer C, right? Let me double check. Yes, answer C. Answer C. All right, problem number 4 says that the first derivative of the function f of x is given by x cubed minus x squared minus 6x, or in its factored form, x times x plus 2 times x minus 3. What is the x coordinate of each local max, if any? All right, so they kind of did me a favor here. Not only did they, well, they didn't even give me the function, they gave me the derivative. So I already have the derivative, and in fact, I already have it in factored form. So if we take this derivative, f prime of x, in its factored form, the x times x plus 2, x minus 3, we set that first derivative equal to 0 and solve, we're going to get x equal to 0, x equal to negative 2, and x equal to 3. So I'm going to go ahead and plot those guys all on a number line. Negative 2, 0, and 3. And I'm going to go ahead and pick a test value from each one of these intervals. And I'm going to plug that test value back into the derivative of the function. All right, so I'm going to evaluate f prime at, I think, a convenient test value on this first interval. I'm going to choose negative 3. I'll choose negative 1 on this second interval. I'll choose 1 on the next interval, and then I'll choose 4 on that last interval. All right, and then we need to evaluate. So let's plug in. If I plug negative 3 in there, I will have negative 3 cubed minus negative 3 squared minus 6 times negative 3. So for that, I get a value of negative 18. You can double check me here on your calculators. Next, let's evaluate at negative 1. When I evaluate at negative 1, I get positive 4. At positive 1, I get negative 6. And at 4, I get positive 24. All right, do you guys agree with those values? All right, so it's not the actual number that I care about, just really the sign. So this is a negative value, which means on this first interval my derivative is negative. My derivative is positive, negative, and positive. So that indicates that the original function is on this first interval going to decrease. Here it will increase. Here it will decrease, and here it will increase. So this gives me a rough idea of what the shape of this graph is going to look like. So can you read off of this? Do we have a local max? Yes, we have one local max right there. So the local max occurs where x is equal to 0. This is my local max. All right? So answer here, there's exactly one local max. It occurs at x equal to 0. Answer D. All right, so problem number 5, I have to tell you guys my personal opinion about this. I really hate this problem because the these graphs are real. They could have given a much better graph. These graphs are a little bit hard. It's a little bit hard to tell exactly what they do. So I'm always looking for a place, like kind of like a handle, a single point that you can kind of move around and you can kind of see what happens to that single point. What they're asking us here is that this is the graph for a function f of x. So I'm going to go ahead and say that the max value here, it almost looks like that critical point where I reach my max. Maybe right here, maybe it's just a little slightly to the left, but it kind of looks like the point 1, 2. It's a little bit less than 2. This is why I don't like this problem. All right. So what we're going to do is the following. We're going to find the graph of f of x plus 1 minus 1. So what this is going to do, the f of x plus 1 minus 1. So the plus 1 is going to cause a horizontal shift, and it's going to move my graph 1 unit to the right, to the left. Not to the right, to the left. I got it backwards. All right. 1 unit, to the left. Whereas the minus 1 over here is going to move my graph 1 unit down. So I'm looking for a graph that has been shifted 1 unit to the left and 1 unit down. All right, so if I kind of grab this dot right here and we move 1 to the left and 1 down, which graph matches? It looks to me to be, so if we move 1 down, if we move 1 down and 1 to the left, it looks to be B. Would you guys agree with that? It looks to be B. It looks like E has only been moved 1 unit down. This guy's been moved up, this guy's been moved up, this guy's been moved down, but to the right. So I'm going to go with B as my answer. All right. I'm going to go with B. All right, problem number 6 says that a rectangle has its base on the x-axis and its upper vertices on the parabola y equals 4 minus x squared. What is the largest perimeter such a rectangle can have? Not the largest area, the largest perimeter. All right, so first of all, I'm going to point out to you guys that if we consider this point where the vertex of the rectangle touches this parabola, let's call that a point x comma y, then we're going to go ahead and describe the perimeter here. So the length from the y-axis to this point, so this distance right here, this right here is a distance x. And then this right here is a distance y. So we're going to make use of the symmetry. This guy here then will be called x, and of course this is also going to be called y. All right, so what we're doing here is we're optimizing. Specifically, we would like the largest perimeter. So let's give an equation for the perimeter. So the perimeter here will be y plus x plus x plus y plus x plus x. So it will be 2y plus 4x. All right, this describes the perimeter. But right now, this perimeter is a function with respect to 2 variables. This is my objective equation. This is the equation I'm trying to optimize. Right now, I have 2 variables in here. What was my constraint equation here? What can I use to eliminate one of these 2 variables? We are given that y has to be on this line, or this curve. Y equals 4 minus x squared. So we can substitute this guy in here for y. So the perimeter then, as a function of x, will become 2 times 4 minus x squared plus 4x. All right, I'm going to clean this up just a little bit. So the perimeter is equal to 8 minus 2x squared plus 4x. And I'm going to go ahead and take a derivative. All right, so this is my objective equation. So the derivative, p prime of x, will be equal to minus 4x plus 4. I'm going to set this derivative equal to 0. All right, so because one of my terms already is negative, we get that 4x is equal to 4, which means x is equal to 1. Now the problem here did say what is the largest perimeter. It didn't ask me to find x and y, it wanted the largest perimeter. So since I have this equation for perimeter already, this is the x value that optimizes the perimeter, plug it in there. So that max perimeter will be this equation p evaluated at 1. So it will be 8 minus 2 times 1 squared plus 4 times 1. This is equal to 10. And this is going to be whatever units. They did not define units. So my answer here will be D. This will be equal to 10 units. All right. Number 7 says determine the values of b and c so that the function f of x equals bx plus 4 on the interval x less than 1, x squared on the interval negative 1 to 2, and x plus c on the interval x greater than 2 will be continuous. All right, so for continuity, we know that all of these guys have to be equal to each other, right? So for continuity, I know that the limit as x approaches a from the left for some function f of x must be equal to the limit as x approaches a from the right for that same function. So I'm going to be setting these limits equal to each other. So step 1, let's set the first two equations equal to each other. So I'm going to say that the limit as x approaches negative 1 from the left for this function has to be equal to the limit as x approaches negative 1 from the right for this same function. All right, so I can go ahead and find these limits. I can in fact just plug in negative 1. So if we plug negative 1 in here, I will have b times negative 1 plus 4 will have to be equal to negative 1 quantity squared. All right, so this means negative b plus 4 is equal to 1. So therefore, negative b is equal to negative 3 if I subtract 4 from each side. Therefore, b has to be equal to 3. At the same time, the limit as x approaches 2 from the left-hand side will have to be equal to the limit as x approaches 2 from the right-hand side for this function. All right, so we're dealing with these two equations. So on the left-hand side, as I approach from the left, or as I approach, actually I switched these two around, because I did left and right. Limit as I approach from the left, from the right. It doesn't matter. I just switch these two guys around. Let's switch these two around too. The limit as I approach from the right, the limit as I approach from the left. So as I approach from the right, we're dealing with this guy, the x squared. So I'm just going to plug 2 in there. As I approach from the left, we're dealing with x plus c. So that'll be 2 plus c. So 4 is equal to 2 plus c. If I subtract 2 from each side, I get that c must be equal to 2. All right, so answer here, 3, 2. Answer here will be A. All right, problem number 8. A particle moves along the x-axis and its position at time t is given by x of t equals 200t minus t cubed for all t greater or equal to 0. T is measured in seconds and x is measured in feet. What is the average velocity from t going from 5 to 10? All right, so we know that velocity is equal to distance over time. And so in this case, because we're looking for the average velocity, it'll be the change in distance over the change in time, or the change in position over the change in time. So I can go ahead and calculate the change in position from 5 to 10 seconds by calculating x of 10 minus x at 5 divided by 10 minus 5. All right, so here we go. This will be equal to, if I plug 10 in here, this will be 200 times 10 minus 10 cubed minus, if I plug in 5, this will be 200 times 5 minus 5 cubed. All of this divided by 10 minus 5. All right, I'm definitely going to use my calculator here. So I will get I get that this is equal to 25. And so again, because this is a velocity, this will be measured in feet per second. So let's see, is that an answer option? Yes, it is. 25 feet per second. All right. All right. Problem number 9 says, as in problem 8, a particle moves along the x-axis and its position at time t is given by x of t, the same equation. Here we would like to know what the instantaneous velocity is going to be when t is equal to 7.5. So instead of average, instantaneous velocity means I'm going to have to find a derivative and then evaluate at 7.5. So the instantaneous velocity function is going to be equal to the derivative of x of t, which is equal to, if I find my derivative here, this will be 200 minus 3t squared. All right, we can evaluate at 7.5. That'll be 200 minus 3 times 7.5 squared. 200 minus 3 times 7.5 squared. I get 31.25. Again, this will be feet per second. So this time the answer is D. All right. Problem number 10 says that a square is measured to have a side length of 20 centimeters with a possible error no worse than plus or minus 0.04 centimeters. Use differentials to estimate the maximum error in calculating the area. Well, first of all, let's find a differential. I tell you what, let's find a derivative first. So if I have an equation, what describes, so help me out here, what describes the area of a square? Area of a square is given by? Just its side square, right? Area is equal to side square. So if I find a derivative here with respect to s, all right, that means the derivative of a with respect to s will be equal to 2s, correct? So differential means we're just going to take this ds, multiply it out to the other side. So dA, the differential, is equal to 2 times s times ds. Now I'm going to remind you that dA describes the change that occurs in the area. ds describes the change that occurs in the side length s. So what we have here is the original side length s was equal to 20 centimeters, and that possible change, that ds, is equal to plus or minus 0.04. centimeters. So this detail is going to be plugged in here. All right, so dA is equal to 2 times S is equal to 20 times ds, and we're going to evaluate at both positive or negative, so you can put a plus or minus in there, 0.04. So I get 2 times 20 times 0.04. This will be equal to plus or minus 1.6. So answer here will be D. And remember, this is a change in area, so measured in centimeters squared. All right, number 11 says that the derivative of a function f of x, again, is given by 3x squared minus 90x. So they give us the function, they give us the derivative, and they go ahead and proceed to factor it for us. Determine the absolute maximum value and the absolute minimum value. All right, so anytime we're looking for absolute values, absolute min, absolute max, we know the absolute min or max could occur at one of two places. Either it could occur at one of the two endpoints of the interval, or it could occur at one of the critical points inside of that interval. So the first thing I'm going to do, I'm going to go ahead and find those critical points. So step 1, f prime of x in its factored form is equal to 3x times x minus 30. Now set that equal to 0 and solve. So when we solve, we get that x is equal to 0 or x is equal to 30. So my question to you is this: are both of these two critical points on the interval of interest? This guy is not, so we're not going to use him. We're only going to use 0. So I'm going to be evaluating the original function at my endpoints and every critical point on that interval. So that will be evaluating it at negative 10, evaluating it at 0, and also at 20. And let's just see what we get. All right, so if I plug in, I will have negative 10 cubed minus 45 times negative 10 squared plus 15,000. So for negative 10, I get a value of 9,500. If I plug in 0, of course, I get a value of just 15,000. And when I plug in 20, I get a value of 5,000. All right, so I can see that this guy right here is my max, and this guy right here is my min. So that absolute maximum value is going to be 15,000. The absolute minimum value is going to be 5,000. So answer here looks like answer B, right? Answer B. All right, there you go. It took us an hour to do parts 1 and 2, so time-wise, we are still in very good shape. We may yet be able to go out on Friday nights. All right. Free response part says the following information is known about a function f. All right, part A says that both the function f, the first and the second derivatives, are continuous functions defined for all values of x. That really actually is a big deal. That's really nice because it means I'm not going to have to deal with any sort of asymptotes or any parts of my domain that's undefined. That makes things really nice. All right, part B gives me all of the values where both the first and second derivatives are equal to 0. Hence, it gives me the critical points and the potential inflection points, right? So let's just deal with intervals of increase and decrease and min-max values first. So we're just dealing with the first derivative right now. The first derivative is equal to 0 when x is equal to negative 4, negative 1, and 2, right? If you want to, go ahead and plot that. Negative 4, negative 1, and 2. So those are my critical points. It does tell me what each one of these intervals are going to do as far as whether they're negative or positive. If you look at part C, it says f prime of x is greater than 0. It's positive on the interval where x is less than negative 4. So it tells me that the derivative is positive here. So here we're dealing with f prime of x, right? It says that it's also positive when x is between negative 1 and 2. So between negative 1 and 2, it is positive. It says that the first derivative is negative on the interval between negative 4 and negative 1. So it's negative here. And it's also negative for all x greater than 2. So this tells me about the intervals of increase and decrease for my original function f. So that means on this first interval, I will increase, I will then decrease, I will increase, and again, I will decrease. So we can go ahead and answer some of the questions. On part A, it says, on what intervals, if any, is the function f of x increasing? All right, it's increasing on this first interval, so from negative infinity to negative 4, united with negative 1 to 2. All right, so there you go. There are my intervals of increase. Part B says, for what values of x, if any, does f of x have a local maximum? Well, I see two max values. I see a max value right here, and I see a max value, local max value right there. So that will be for the x values, x equal to negative 4, and also for the x value that is equal to positive 2. All right, questions C and D deal with the inflection points and the concavity of the function. So I'm going to draw a new little graph here. All right, so again, here in part A, or in part B, it said that the second derivative is exactly equal to 0 when x is equal to negative 2, 0, or 5. So remember, unlike critical points, inflection points are not guaranteed until we show that the function actually does change concavity. So that's why we call these guys the possible inflection points, right? So let's see what happens here. It says f double prime of x is greater than 0 when x is on the interval between negative 2 and 0. So between negative 2 and 0, I am positive. And for all x greater than 5. So we are positive. F double prime of x is negative when x is on the interval less than negative 2, and x is on the interval between 0 and 5. All right, so I do, in fact, I can see now, verified, I do change concavity at each one of these points, and so that means the original function f of x will be concave down, and up. All right, so we can answer the questions here. On what intervals is the graph of f of x concave down? It will be concave down on the interval from negative infinity to negative 2, united with interval from 0 to 5. And then part D, for what values of x does the function have an inflection point? Well, we see that all three of those guys are going to be considered inflection points. So this will be x equal to negative 2, x equal to 0, and x equal to 5. Let's do the next one. All right, problem number 2 says, let's use Newton's method to approximate where f of x equals x cubed minus 3x squared minus 5x plus 15 has a 0. Start with x sub 1 equal to 1 and calculate x sub 2 and x sub 3. All right, so your problem did not give you this cute little grid that I just drew here. You're welcome. Go ahead and draw that for yourself. That way you can sort of in a most organized way, share your work to the graders. First thing that we need to make sure of, in this case, the function is being provided. Sometimes they provide me with an equation. If the equation has been provided, make sure that the equation is set equal to 0, and then you give that part on the side of the equation as f of x. All right, so we can go ahead and just simply find f prime of x here. So f prime of x is equal to 3x squared minus 6x minus 5. And I'm going to start here. I'm going to call this is going to be my x sub n. This will be my f of x sub n, f prime of x sub n, and then finally f of x sub n plus 1 will be equal to, according to Newton's method, this will be x sub n minus f of x sub n divided by f prime of x sub n. Or I like to call this, I'm going to give these columns names. I'm going to call this column A, column B, column C, and then this last column will be A minus B over C. All right? So I'm going to use my calculator here. All right, so x sub 1 is equal to, is given to me, it is equal to exactly 1. All right, so on my calculator, I'm going to see if you guys, you may or may not, I think you can, let's see if you guys can see my calculator. What I'm going to do is I'm going to go ahead and store into my calculator. I'm going to put in 1, and I'm going to store that as alpha A. All right, can you guys see? Let me see if I turn the lamp off, if it, that doesn't make it better at all. Okay, well, sorry, this is best I can do here. In a second, I will make the screen a little bit bigger. I just want to make sure everybody can see what I'm doing. All right, so now I'm going to type in the original function evaluated at A. All right, so the original function evaluated at A is going to be, this will be A cubed. All right, minus 3 times A squared minus 5A plus 15. All right, and I'm going to evaluate, that's equal to 8. I'm going to store that as alpha B. So this is equal to 8, and we stored it as B. All right, I'm also going to evaluate the derivative at A. So the derivative is equal to 3, let's see, alpha A squared minus 6 times alpha A minus 5. And so I get negative 8. I'm going to store that as alpha C. All right, so this is equal to negative 8. All right, so we can then calculate x sub 2 will be equal to 1 minus 8 over negative 8, or I'm going to put in my calculator here, I'm going to type in A minus B over C. I get a value of exactly 2. So I'm going to round x equal to 2 down here. So x sub 2 is equal to 2. And I'm going to repeat the process. To make it a little bit easier on my calculator, I'm just going to store this 2 as my new value for A. If you have a newer calculator like the one I'm using, you don't even have to type anything back in again. Just go back up and pull up again the original function evaluated at A. That's equal to 1, and I'm going to store that as alpha B. I get that this is equal to 1. Double check my values here. I'm also going to evaluate the derivative at A. And again, I'm going to store that as alpha C. That's equal to negative 5. And then again, finally, to get x sub 3, I'm going to calculate A minus B over C. And I get a value of 2.2. All right, did you guys get the same values? Good. And so this is all we need to do. We were just asked to give, and I would probably report my answer here. I would say x sub 2 is equal to 2, and x sub 3 is equal to 2.2. Just make sure that whomever is grading your test sees that final answer, kind of blocked, neatly written down. I know that it's really easy to use your calculator to get these values without writing down anything. But again, this is part 3 of the exam, so our answers have to be proven. So do make sure that you write down your process. All right, problem number 3. We are going to use the following table to calculate a few derivatives. All right, so in part A, it is given that r of x is equal to f evaluated at g of x. It is a composite function. We are looking for r prime evaluated at 2. All right, so since this is a composite function, I know I'm going to use the chain rule. So r prime of 2 will be equal to derivative of the outside. So f prime, leave the inside alone, g of 2, times derivative of the inside. So g prime evaluated at 2. All right, so for these problems, start on the inside, work your way out. G of 2 is equal to what? So here's g. G of 2 is equal to 4. So this is equal to f prime evaluated at 4, g prime evaluated at 2. All right, let's look up those values. F prime evaluated at 4 is equal to 20. G prime evaluated at 2 is equal to 9. All right, 20 times 9 equal to 180. All right, part B. We like to calculate h prime of 3 for h of x defined to be f of x divided by g of x. So that means we're going to use the quotient rule here. So by the quotient rule, derivative of a product is going to be derivative of the top. I hate slant fractions like this. H of x is equal to f of x over g of x, of course, right? All right, so it will be derivative of the top, so f prime of 3, times the bottom, g of 3, minus the top, f of 3, times derivative of the bottom, g prime of 3, all over the bottom squared, all over g of 3, quantity squared. All right, let's see what those values are going to be equal to. All right, f prime of 3 is equal to 5. G of 3 is equal to 2. F of 3 is equal to, I'm sorry, this is wrong. F prime of 3, I looked in the wrong column. F prime of 3 is equal to 8, sorry. F of 3 is equal to 5, and g prime of 3 is equal to 14. Again, everything divided by g of 3. Of course, g of 3 we said was equal to 2, quantity squared. All right, so calculate. This is going to be negative 54 divided by 4, negative 13.5. All right, number C says if k of x is equal to x squared times f of x, then k prime of 5 is equal to what? So they defined a new function x squared here for me. I'm going to have to use the product rule because I have a product between two things. All right, so k prime of 5 will be derivative of the first. The derivative of x squared is 2x. I'm going to go ahead and plug that 5 in, so it'll be 2x, derivative of the first, times the second, f of 5, plus the first, x squared, times derivative of the second, f prime evaluated at 5. All right, so let's look up those values or calculate. 2 times 5 is 10. f of 5 is equal to 1 plus 25 times f prime of 5 is equal to 4. All right, 25 times 4 is 100 plus 10. This will be equal to 110. So far, the free response part's not bad, right? I think these are easy problems. All right, problem number 4 is not bad, if only for the reason that you guys have already worked this problem in class in your notes, right? It says that a rectangular poster is to be printed with 1-inch margins on each side and 2-inch margins at the top and bottom. The total printed area is to be 242 square inches. What are the dimensions of the printed part of the poster that uses the least amount of material for the entire poster? All right, so I remember I worked this out 2 ways. One way is a little bit easier than the other. It all depends on how you decide to set it up, but let's do this. I'm going to go ahead. So let's go ahead and just indicate for ourselves these little margins that are given here. So remember, at the top and bottom, this is a 2-inch margin. This is a 1-inch margin. Same thing down here. This is a 2-inch margin. This is a 1-inch margin. All right, so if we're dealing with this printed area, I'm going to go ahead and call this printed area, so this length from here to here, I'm going to call this x. And then this length right here, for the height of this printed area, I'm going to just call that y. You guys okay with that? All right, so the total printed area has to be equal to and so let's quickly give a definition for the printed area. The printed area will be x times y, and that is going to have to be equal to 242 square inches. What are the dimensions of the printed part of poster that uses the least amount of material for the entire poster? So what we want to do is we would like to minimize the area for the entire poster. All right, so the entire area will be equal to, so this will be x plus 1 2 inches, x plus 2, and this will be y plus 4. All right, so first of all, the way that I set this up, is everybody okay with this? Everybody good? All right, so from this equation down here, this is our constraint equation. We can solve for either one of these variables. I'm going to solve, it doesn't matter, you can really solve for either one. I will solve for y. Y is equal to 242 divided by x. We can substitute that in here and get that this area, and I'm just going to call it area then as a function of x, will be x plus 2 times 242 divided by x plus 4. All right, I'm going to clean this up. I'm going to definitely FOIL out here. So when I FOIL out, this area equation is going to be, let's see, x times 242 over x. That's just equal to 242, first times first. All right, when I multiply the insides together, 2 times 242 over x, this will become plus 484 divided by x. Multiply the outsides together, 4 times x. Well, that's just 4 times x. And then finally, last times last, 2 times 4 is plus 8. I can't really clean anything much more up here. I'm going to go ahead and optimize. So that means take a derivative, set it equal to 0, solve for x. All right, so a prime of x is equal to derivative of a constant, 0. Derivative of a constant is 0. All right, so what is the derivative of, let's take this 484 as a coefficient. Let's take it out for a second. What's the derivative of 1 over x? Negative 1 over x squared. Put the coefficient back in. So negative 484 over x squared plus 4x, that's going to be equal to 0. I'm going to move this term to the other side. I'm sorry, it's just 4. Sorry. It's just 4. Yes, you're right. It's just equal to 4. All right, I'm going to subtract, let's see, I'm still going to take this term to the other side. So I get that 4 is equal to positive 484 over x squared. I'm going to multiply x squared over here on this side. Excuse me. And if you want to, you can go ahead and just take the square root of each side, or if you want to divide first by 4. Let's see, what is 484 divided by 4? Equal to 121. If I take the square root of both sides, we get that x is equal to plus or minus 11. Of course, the negative answer here does not make sense in the context of the problem, so we're looking for x equal to positive 11 here. All right, so if x is equal to 11, let's make sure we answer the questions. It says, what are the dimensions of the printed part? So we need to give those values for x and y. So if x is equal to 11, then y will be equal to 242 divided by 11. That's equal to 22. So I'm going to go ahead and give my answers here. Remember, we measured in square inches. So this will be 11 inches by 22 inches. by 22. Again, make sure that you answer the question. Go back, read again. What was it? Did they ask what is the maximum area? What was it that they asked? Make sure that you answer the question. Make sure that there's units on your answer. Block your final answer. All right? Yes? That's fine, yeah. I mean, we want to just see that you were able to find those two dimensions. But yeah, just put units on them then. Stick units on them, circle them, you're good. All right, problem number 5. All right, so it says a large conical shaped tank is being filled with water at a constant rate of 8 cubic feet of water per minute. The diameter at the top of the tank is 40 feet and the height of the tank is 60 feet. How fast is the depth of the water changing when the water is 20 feet deep? The volume of a cone is being provided here for you with respect to its diameter. All right. Let's see. How fast is the depth of the water changing? All right. Goodness, I hate working with diameter. That's just terrible. Should we continue working with diameter or should we switch it to radius? What do you guys think? Just leave it as diameter? All right, they gave it as diameter. We'll leave it as diameter. I mean, it's very nice. They converted everything for us. All right, so let's go and pick out what is being provided for me in this problem. So it says here that, all right, the water is being poured in at a rate of 8 cubic feet per minute. What is this that's being given? 8 cubic feet per minute is coming into the tank. What rate are they giving me there? What is changing? The volume, right? So I'm going to just write that down. So dV dt is equal to 8 cubic feet per minute. All right, so that is the rate at which the volume is increasing. All right, so they provide me with the diameter at the top and they provide me with the height. How fast is the depth of the water changing? This is the question. What am I solving for? When we talk about the depth of the water, we're talking about that height, h, right? So dh dt, the rate at which the height of the water is changing, is what I'm solving for. All right, that's what I'm going to try and find. However, right now, this equation with respect to multiple variables, this is kind of tricky. Volume is equal to 1 over 12 times pi times d squared times h. I would like to eliminate, since I only have information about the rates of the volume and the height. I'm solving for the height, I have the volume. I'm not being asked about the diameter, nor am I being given any information about the diameter. Let's eliminate diameter. All right, so for this particular conic-shaped tank, what is the relationship between the diameter and the height? So if you want to give it as the diameter over the height, here for this particular guy is 40 over 60. Is that not true? The diameter is equal to 40, the height is equal to 60. We can solve for d here. Multiply each side by an h. So the diameter is given as 40 over 60, or simply just 4 over 6, or even, if you will, 2/3 the height. The diameter is 2/3 of the height. So we can go ahead up here and eliminate diameter. So volume is equal to 1 over 12 times pi times 2 over 3h squared times h. I'm going to clean this up. So when we square this, 2 squared over 3 squared, that's going to be 4 over 9. So volume is equal to 1 over 12 times 4 over 9 pi times h cubed. Again, one more time, if you want to combine this, 4 over 12 is equal to 3. So the volume then here becomes 1 over 27 pi h cubed. All right, so finally I have that equation that I'm going to go ahead and find the derivative of with respect to t. This is a rate problem. This is not an optimization problem. This is a rate problem. So let's find the derivative with respect to t. All right, so the derivative of v will be equal to dv dt. This is equal to, derivative of h will be 3 over 27 pi times h squared times dh dt. All right, so since I'm solving for dh dt, if at this point in time you want to plug in everything that you know and then solve for dh dt, absolutely fine. I like to solve for dh dt first. So if you start moving all of this stuff to the other side, we get that dh dt is equal to, let's see, it'll be dv dt. If I move the 3 over 27 is the same thing as, this is the same thing as 1 over 9, right? If we move 1 over 9, we could really just multiply the 9 up on this side and then divide both sides by the pi h squared. All right, we know all of these values. Let's plug it in. So dh dt will be equal to, dv dt is equal to 8 times 9 over pi times, we said that we would like to find this when the water is 20 feet deep. All right, so we plug in and we evaluate. So 8 times 9 divided by pi times 20. Actually, you know, let me eliminate. Did I? Oh, I forgot to square it. Okay, sorry. All right, let me punch it all in here. 8 times 9 pi times 20 squared. So I get here a value of 0.0572955, and I'm going to round it, so this is really 77. I'll round it to 78. If the problem does not tell you how to round, like in this case it did not tell me, like round to 3 decimal places, give all of the digits that your calculator give. I would say probably at least 8 decimal places. All right, what is the unit here? The rate at which the height changes is going to be? Feet per minute. All right, questions for me? Yes. This one, the absolute min-max problem? Because we're only interested in the interval from -10 to 20. You see? We're only working, we want the absolute min and max on this interval. 30 is outside of this interval. Okay? I can't hear. 30 is what? I can't hear you. Come up here. All right, other questions? I can't hear. You're going to have to like scream it at me. All right, so if you guys would like some more practice problems, remember that on, let's quickly minimize this. You can go to the math department's website, which is just math.uncc.edu. You guys are undergraduate students, so go to undergraduate program information. If you scroll down, one of the items will be past common final exams. Choose your class. You guys are in 1241, and there's a whole list of old common final exams that you guys can go and look at again. Well, yes, you can. The keys are sold by the bookstore. That's why we can't. We're not allowed to host it. But it's not expensive. Maybe see if you can find some friends who want to go in on it.
I thought when you took like the derivative, I know the derivative is e to the x is e to the x, but I thought it was the constant it would have been just the x. So like why do we choose it?
It's not a constant. It's a coefficient.
Okay,
Coefficients hold over.
right.
Coefficients hold over.
Okay, that was only how I was like
Okay.
wait a minute,
Yeah. Coefficients hold over.
right. And then my other question is here. So I understand that we like memorize the areas, but like when you made like the entire area, how do you know like it would be like the x?
This is the outside. So we decided to, we call the inside, we call x times y. Right? So the outside, you see that that is going to be this x plus the x, the 1 inch and 1 inch. So it becomes x plus 2.
Okay.
And this becomes x by y plus 4.
Oh, okay.
See, so that's
Right,
the
like
entire area. So the big outside one will be those dimensions.
Okay. Right, and then like the printed would be
It's just the inside. It's the x by y.
okay, I got it. Okay, that's why